Hello, assalamu alaikum. Hello, hello.
عليكم السلام ورحمة الله وبركاته.
So sorry for late. So now we will start our today's session, and you are also
إن شاء الله.
requested me to some tasks such as evapotranspiration for monthly data set, as well as also animation NDVI TP images. Okay, so first of all, I will try to complete this two part, then move to the change detection of land use land cover change detection. Okay, so let's go. So okay, so now can you see my screen?
Yes.
Okay. Okay, so first of all, we will try to discuss about that evapotranspiration, this 8-day global 50-meter resolution data set. Not only for that data set, any data set. It can be NDVI, it can be NDWI, or any types of data set when you want to make the monthly composite. So in this time, when I want to make this data set and make the time series chart, I can get the every 8-day interval, because it is a 8-day global. Okay, but when I want to convert this 8-day into monthly, then I can get the chart monthly. Suppose January, February, March, April, May, June, July, this type of month, get the chart monthly. And it's not only for the evapotranspiration, any types of chart, it can be NDVI, NDWI, or any types of data set, you can easily apply the same process, and you can easily get the monthly time series chart. Okay, so first of all, I try to discuss about that. And evapotranspiration, what is that? You can get all of the information about that in here. So in this time, I will not go in here. So I just show you that how you can easily make the monthly time series chart using this data set. Basically, this is the 8-day. So now we can convert this 8-day into monthly. Okay, so before that, here you can see, here we can already create a work for the NDVI and LST. So basically, this chart, you can see when I click here, I can get this specific coordinate in here. And in this coordinate, what happened for the different month for the NDVI and LST we can get. We are also using the same code when I want to work with the evapotranspiration, because the same process, when you want to convert monthly any chart, we can use the same code. Okay, so you can see now I can get this NDVI monthly. I simply click on here. So here you can see I can get the chart look like this. Basically, in this time, I want to extract the data for 2005, 2010, 2015, and 2020. Okay, monthly. So when I want to download the CSV file, you can see I can get the 2005 all of the month, 2010 all of the month. You can see 2005 I can get all of the monthly data, 2010 I can get all of the monthly data, 2015 I can get all of the monthly data, and finally 2020 I can get all of the monthly data. Okay, so the same code we can also apply in here for evapotranspiration, which data set I want to work. Same process. I simply take a new code editor. Okay. And work with this data set. Okay. So you can see this band is that ET. This is the total evapotranspiration. Mainly we can use the ET band, and this is the unit. Okay, so now we can simply convert it as a 8-day from monthly. Okay, and this data set also you can see that the scale. So when you can get any data set their scale, you have to must multiply for reprojected the scale value. So it has also a scale, so we need to multiply. Okay, which when we work with the modis NDVI, we also reproject it. Okay, same process also in this time in here. Okay, so first of all, I simply copy this data set from here and paste in my creator. I take a variable, suppose put the variable suppose ET. Okay, So now all of the things will be stored in the ET. Okay, so now I use the same code for, okay, it also save our time. Okay, so in this time, first of all, I need to reprojected the scale value for this data set. Okay, so in this time, I need the data set for a specific region. So I simply input my boundary shape file. Suppose I need the data set for region of Dhaka city or Dhaka city boundary. I simply import my shape file and put this name, suppose ry, okay, and then I simply use the filter, suppose filter bounds with ROI. Okay, after that, so first of all, then we need to simply copy this code from here. So simply copy and paste. Suppose in this time I want to need the data set from January to December. So 1 is January and 12 is the December, and I make a sequence, list sequence. So it will be start from the January, February, March up to December, and I need for the specific time period, a specific year. Suppose 2005, 2010, 2015, and 2020. So like the chart, you can see which year I put, I can get the chart according to this time period for the monthly chart I get in here. So in this time, if you which year you want to need, simply put this time period and you can easily get the chart. Okay, after that I need to make a collection, feature collection. This feature collection convert the 8-day all of the images for my specific region, convert into monthly. Okay, so this is the function. I simply copy and try to run. So I simply copy this, and this code is the same for all of the code. Just we need to change here the band name, as well as also change the resolution of your satellite images, but all of the things will be same. So I simply paste in here. So in this time, here code, you can say I can simply take a variable name by year month, and you can use any variable name, there is no problem. Then use here the e feature collection. Okay, I want to create the feature collection according to these years, all of the years. So I simply call the years. Okay, and then you can see I create the map. Basically this is the function. This map function mainly connecting. You can see this is the function, one function, and this is the element name, and this is the curly bracket. This curly bracket we can simply put our argument, what I want to need. You can see it will be start from here and in here. Okay, and in this time I can simply create a function for years. Okay, and also I want to return another function for month. Okay, so I use here the, I can see return and make the months, and use here the map function. In this map function I want to define m. Okay, in this time I simply, in this time, the mean LST showing it variable name. You can use any variable name, there is no problem, but it's important, a scaled NDVI. A scaled NDVI means that our image collection, all of the image collection. So in this time I want to just scale NDVI, this is our image collection. So in this time it will be changed, because in this time I want to use here the another variable, such as when I want to get all of the image collection. Suppose I want to simply put here, suppose filter. So I simply put here this filter date. Okay, and put here this time period, suppose 2000, suppose 2000 from 2000 1st January from 2020 December, suppose 31. Okay, I check the data time period, you can see 2001 from 2020. Okay, so we also need to change here, because it will be start from the 2001. Okay, so I simply put here the, suppose, okay, 2002, there is no problem, and 2020. Okay, so I simply put this time period in here. Okay, so in this time it will be comma sign. Okay, it's done. So in this time, I can get all of the image collection. You can see when I want to print this, I simply print and then ET. Okay, we also need to select our band name. So just I simply use the select function, select, and also select this band. You can see which band I want to work. I want to work ET band. Okay, simply copy and paste. Okay, so now I want to check how many images I want to get. I simply call this variable name ET and click on the run. So now you can see it will be calculating image collection, how many images I want to get. So here I can get total 874 images. Okay, and what is the time duration? You can check the time duration. Each image we can get the time duration 8 days. You can see the first image, then you can see 1st January, 9th January, 17th January. So is we can get the time interval time period is that 8 day. Okay, 8 day time period. So now this 8 day time period I need to convert as a monthly. Okay, so in this time this 874 is my image collection. Okay, so I simply copy, and in this time I did not reproject it. Okay, so I before that I also try to show you that, then I also show the reprojected how you can easily do. Simply copy, and I use here this in here because this is my image collection. This collection here I can get total 874. This 874 I want to create monthly composite according to this year. Okay, so all of the things I already set in here. So just I simply paste this image collection variable name ET. Okay, it's done. And then all of the things will be same. There is no problem. And then select which band you want to use. In this time I use at this band. You can see ET. Simply copy the ET and then paste instead of the NDVI. Okay, and I calculated the mean. Okay, after that all of the things will be same. I can simply change the resolution. In this time this resolution is that 500 meter, so simply use at the 500. Okay, then all of the things will be same. I simply copy this variable name, it can be anything, and then paste here and set year. Okay, y monthly, all of the things will be same. There is no things. I simply click to the run. We can check what happened. In this time you can see here I can get 48. So in this time I can get the 48 because you can see for 1 year I can get total 12 month. Okay, for 1 year I can get total 12 month. So total 4 year I can get 4 into 12, 48. Okay, 4 into 12 I can get 48. So it is my image collection. Now this image collection, first of all I can get 874 when I want to use at the 8 day interval, but when I want to apply this for each year I can get the monthly. Suppose this year I can get the 12 month, this year I can get 12 month, this year 12 month, and this year 12 month. Total 48 image collection I can get. You can see, simply click on here, you can see all of this 48. So just I simply click on here, you can see, you can say I can get this value January 2005. What is the value of the ET? I can get the value. So also you can see for the February 2005, what is the value of the ET? I can get this value. So February, you can see this value. Suppose 2005 March, what is the value I can get in here? Okay, so this is the process. So I can create my image collection. This is my image collection. So now I use this image collection and make the time series chart, and it will be represented the monthly time series chart. Using the same process, you can easily convert any data set into the monthly time series. It can be precipitation data set, it can be NDVI, NDWI, or any other data set we can easily apply. Okay, so now I want to create the time series chart such as, so in this time this is my main collection. Okay, I simply use this and make this time series chart. So I simply use the same code from here. Okay, so I simply go with the same code from here. and paste. In this time EVI chart, they can use the variable can be anything. There is no problem. This is the UI chart feature.group, and by year month. In this time, this is the same variable by year month. And in X property, it will be month. X level showing all of the month, and Y property showing the value of the band. In this time, you need to mention here the band name ET. Simply use here the ET. And series property will be year. Okay. Now I just simply click to the run. Okay, before that, okay, we need to print this chart. So I simply use at the print, and simply call this variable name and paste and click to the run. So now it's generating the monthly ET chart, you can see. So now I can get the chart look like this, evapotranspiration chart for monthly. So I simply click on here. I can get the chart look like this. From this, I can easily download the data in CSV file format. Just simply click and open. So now I can get the data 2005 all of the month, 2020 all of the month, 2015 all of the month, and 2020 all of the month. Using the same process, any data set we can easily convert into the monthly. Okay, so I hope you can easily understand about that. Okay, and in this time you can see I did not use here the reprojected. Okay, I also need to reprojected this value because you can see they also provide the scale. Okay, so I need to reproject. When I reprojected this value, then I can get the accurate result. Okay, so I also try to show that for the reprojected how can easily do. It's very easy. Just okay, just you can simply. So okay, so take a variable R and call suppose variable name suppose scaled ET. Okay, and then create a function. Create a function. In this function, I create a element name suppose image, and then put my argument what I want to need. I simply use at the return this image multiply with scale value. What is the scale value? It is the 0.1. So 0.1, and then use at the copy properties. Copy properties. Use at the image and put at the system time start and system time in. I already talk about this code. In this time I need to connection with my collection. So this is the 874. So I simply call this variable name ET and then paste and use at the map function. Simply use at the map, sorry, ET dot map, and then simply use the parenthesis and also close this parenthesis. In this time you can see all of the things I scaled. It is stored in this variable. Simply copy and then paste in here. Simply paste in here. Now I can get this result in the reprojected value of evapotranspiration. I can get the accurate raw data value from here because I reprojected it. You can see now I can get the value look like this. You can see the 22. Also you can see the 21, and this unit is that kg per meter square per. In this time it will be month because I convert this. Okay, in the monthly. When I download this data, I can get the data set. Sorry. Okay, it's this data set. Okay. So I simply open. So now again, I can get the data set look like this when I want to reprojected our scale value. Okay, so I hope you can got my idea, and if you have any question, you can ask me about that. Any question in here?
Yes, I have one question.
Yeah, please.
Can we looking for example, for the everyday measure for evapotranspiration?
Yeah, everyday.
Not
Yeah.
not daily.
So okay, so every day is that you want to make
I mean daily.
daily data set. Okay.
Yeah.
Okay, daily data set, when you want to convert this daily data set, it also some tough, because in this time, this data set, evapotranspiration, this data set mainly combining 8-day. You can see 8-day composite. Okay, so this data set is the 8-day composite. So that's why using this 8-day composite, we can easily create the monthly. But when you want to make the daily, it's so tough. Okay, sometimes some data set also provide the daily. So if you want to check the daily is available or not, is the available, then you can easily create the daily. I simply start daily evapotranspiration. If this data set is available, then we can easily create the time series chart for the daily. But from 8-day, we cannot get this daily. Okay, so what daily reference evapotranspiration? Yeah, some data is also available, but it is the, if it will be globally, then you can easily use. But okay, I check it. Reference evaporation refine is the evapor from the hydraulic probe. Okay, well, it is a reference evapotranspiration daily. This unit is a millimeter. Okay, okay, and this data set is that. Okay, so evapotranspiration defined is a hydraulic reference probe simulate the waiver. Okay, as an each pixel represent the daily evaporation in millimeter. Okay, so if the data set is the global, then we can easily use this, and you can see. Okay, we can also get this data set between this time period. Then we can get the daily data set. So I simply open in here and check if this data set is the globally or not. Okay, some data set has some specific region, so that's a problem. Another problem. If the data set is the globally, then I can easily make this work for the daily. Okay, so I simply click to the run. Okay, sorry, and this data set is available only for this region, I can see. So when you want to use the data set and make the time series chart for the daily, your region only for this boundary. Otherwise, other region is not covered this data. Okay, so this data set is only for this region. So it is another problem. We need the daily global data set. So actual evaporation from the Australian. Okay, this is data set only for the Australia. Just okay, work for data set. Okay, work for
Okay, listen, okay. I understand now.
yeah, okay.
I can.
Okay, so mainly we can use the 8-day and make the data set for the monthly easily. From 8-day, we can easily convert the monthly. Okay, and using this process, any data set we can easily create for a specific year, and all of the month we can easily get any data set, not only for the evapotranspiration. It can be anything. Okay. Okay, so another thing is that, okay, I also send you this practice code, so you also try to practice and also make this time series chart. Okay, so another thing is that you also want to learn about that animation of NDVI. Okay, so mainly animation of NDVI. Okay, so I can simply open my code editor, new code editor. Okay, animation of NDVI. Okay, so basically this code for any, not only for the NDVI, using the same process, we can easily create for any types of data set for making the animation. It can be NDVI data set, NDWI, or evapotranspiration data set using the same process. Okay, so in this time, you can see I simply go to my region of interest. In this time, I want to work for the Bangladesh region. Okay, so in this time I want to, you can see this is the region 1, geometry and geometry 2. So region is that, and I also imported my shapefile, Bangladesh shapefile from USDOS website dataset, USDOS dataset, which provide the international country boundary polygon in here. Okay, and in this dataset, this is my country boundary. Okay, store it in here. So first of all, I need to define a marks to clip the NDVI data. So for that, I can simply take a variable marks, and this is my data set. Okay, from this data set, I want to filter only for the country name equal to Bangladesh. So now, in this time, this marks is stored at the country boundary of Bangladesh. Okay, and then after that, I need to define the regional boundary animation frame. In this time, you can see, and this animation, we can define the, you can see the black portion. You can see this is the black, also black. So basically, this is a frame. Okay, and this frame created from this polygon. Okay, this polygon created this frame. Okay, so for that we can simply define this boundary. You can see, so take a variable. Okay, this variable I can simply create, and in this time I can simply create a function. And this function we can define the date, system time start, and get day and year. Okay, so from this time period, year of 2019 to 2020, we can create this time period, and then we can simply define the filter that identifies which image from complete to collection. So just we can simply print this, right? Okay, then join these two things from here, and then apply the join and convert the resulting feature collection to an image collection. So I can simply apply. You can see the three variable you can here. So this is the distinct ROI, and then collection and filter. So you can join three things in here. Then apply the median reducer among this all of the image collection. So just simply put here this image collection and put the median. Same code we can use, and then define the visualization. This is the visualization code we can simply put in here for the NDVI, and create the RGB visualization image for the animation frame. Okay, we can create a frame in here, visualization, and define the give visualization. Okay, so in this time I can put my region variable name, then dimension I can put here the 600. Then this is the coordinate system EPGS code for the country boundary of Bangladesh. Then frame per second, in this time I use here the 10. So per 10 second it changed. Okay, then put this, print this gift URL. So just we can simply call this RGBS, this variable, and paste it here, and then apply this, and also provide the link. You can see anyone can copy this link and also get this animation look like this. Okay, so I also send you this code. You also try to use this code for your own region, and then if there's any problem you can just contact with me. I also try to fix the problem. Okay, what is the problem? Okay, as well as not only for that, for the any region we can easily, suppose I want to show the result for that satellite images animation for the different time periods. Same process we can easily create. So I also try to show you this code. I simply open a new code editor.